Okay, so next we're going to check k equals 2. So p of a plus b equals p of a plus p of b plus 2 times a times b.
And then
P of 1 is 1.
right.
Well, p of 2 is p of 1 plus p of 1 plus 2 times 1 times 1. So, 4?
Do you agree? Is
Right.
p of 2 4?
Yes.
Okay, can you tell me what p of 3 is?
So P of 3 is 2, so B. P of 2 plus P of 1, that's 5. And then 2 times 2 plus 1, that's going to be 4. It's 9 here.
Looks like it's going to be the squares.
Well, let's see. P of 4.
So let's do it 3 and 1 first. So p of 3, 9 plus 1 is 10 plus 2 times 3, 16.
All right.
Alright, 16.
You check now.
So
A different way.
we did 3 and 1 before, we could do 2 and 2.
Okay.
So 2, it's 8. And then 2 times 2 times 2, it's another 8, so it's 16 also.
Interesting.
Looks like this is through the triangular numbers beforehand.
I mean,
now we
the
have the
squares.
squares.
The pentagonal number is next.
How do you think?
It's possible.
It's possible. Do you have any hint on here for why you think you get the squares?
Well, because... Well, maybe it has to do with the extra a times b somehow.
Yeah. So you think p of n is n squared,
Yeah.
right? That seems definitely true for 1 and 2 and 3 and 4. Let's use the rule and see if we can see what p of n plus 1 would be. If we know if p of n is n squared, what's p of n plus 1 going to be? What's the rule going to say?
It's p of n
P of n,
plus p of 1
p of 1.
plus 2 times n times 1.
So
just 2n.
2n.
So we have p of n is n squared, apparently.
And then plus 1.
Plus 2n. So n squared plus 2n plus 1, which is actually n plus 1 squared.
Did you know that n squared plus 2n plus 1 is n plus 1 squared?
No, but
Yeah.
it kind of makes sense now.
Okay. So actually, this is called proof by induction. I'm being a little tiny bit sloppy, but we see that it works in the beginning, and then we see that if it's true for one number,
It's true for the next number.
it's true for the next number.
So it's just sort of infinite ascent.
That's right. But you do have to check that it's true in the beginning.
Well, it's defined to be this.
Yeah. And the pattern works initially.
Yeah.
So that gives you a hint it's n squared, and this tells you that if it's true for one number, it's true for the next number. Okay, so you think if I put 3 on here, I would get the pentagonal numbers. Is that's what you think?
Yeah.
Okay.
Test it.
Yeah, let's do it. He asked a different question, but I think that's a great idea. Let's test and see what happens when we get 3 here. First, I'm going to have to look up what the pentagonal numbers are.
Yeah.
What's the first one, do you think?
1.
And then
I think it's 5.
5? Okay. So let's see. I'll look them up real quick.
Right.